back to Doz's television workshop.
Well, saves me the bother, I suppose. Yes, welcome back. And if you watched last week's fun-packed episode, you'll know we made an HF linear loaded doublet, if there is such a thing. Is it going to work? Who knows yet. What we need to now do is match the oddball impedance of that antenna to our 50 ohms unbalanced output from our transceiver. Right, let's have a look at the plan. Can't you tell I'm British? Look, tea stains on the paper. Right, as discussed last week, I was looking for last week's diagram, but to be honest, I filmed it about 3 weeks ago, and I've been very busy with a commercial thing in the workshop. That's now finished, so we can make some more stuff for you. Right, so the antenna, it comes down to a piece of ladder line up here. So there's our ladder line coming down from the antenna. Now, at the other end, we've got our radio. I shall draw my radio again. Curly lead and a microphone. Lovely. There it is. So the output here is 50 ohms, and that's unbalanced. So unbalanced means we've got a single conductor and then a braid around it, which is grounded. And in the ideal world, you don't want any signal flowing in that shield or ground. You don't want current flowing in it because it'll tend to radiate. So we want to try and avoid that. Yeah, so this impedance up here at the bottom of our antenna is going to be X, the unknown number. The simple reason is this antenna is more than likely not resonant. It's also a balanced antenna. So this is balanced. Now, if you've got an ordinary dipole, you can do the bodge of just feeding it with a piece of coax. But because the dipole is really a balanced antenna, it's maybe not ideal because you generally get a bit of common mode current and your coax radiates a bit. Now, the reason we've used ladder line here is even if we did try and balance our coax, the problem is it would be very, very lossy. And if we try and put a high SWR on a coax, we end up with a lot of loss. If we do it on a ladder line, not so much. I believe we can throw away something like about 1/8 of our power away in the ladder line if it's really badly mismatched, rather than many factors into the coax. So that's a good thing to have. So we can have a long line, a ladder line, that hoists up on our stealth bright orange rope, which, yeah, is a better situation. It's not ideal, but it's better. So, right, we've got a piece of ladder line coming down there with an unknown impedance on it, and it's balanced. Now, so in between the radio and the unknown impedance, we're going to need to put an ATU. It's really an AMU. ATU stands for antenna tuning unit. It does not tune the antenna. It makes the antenna look like 50 ohms to keep the radio happy. So this becomes 50 ohms here. Now, I have a number of ATUs, and yeah, I'd like that to be in focus. There we go. I'd like that to be automatic if possible. You can get them where you have to manually adjust them. I've got a couple of those, one very much homemade, which will only cope with, I don't know, 5 or 10 watts maybe. It's not ideal. I've got a very old Tech one that somebody tried to put a lot of power through once and did some damage to it, but we've managed to repair that. I've used that in years gone by. But what I'd really like to do is have this automatic, so it's an intelligent unit. Now, I have bought, just for this purpose, I shall go and get it, one of these kits from China. Allegedly 100 watts, but as you can see, I've made this up. The board came populated already with a micro, and I think the surface mounted capacitors there. All this is a bunch of relays. You have to wind the coils yourself. That's an SWR bridge, and it gives you a little readout on a display. Very nice, but as you can see, it's balanced in, unbalanced in and unbalanced out. Not what we need. We need to turn that into a balanced line. So after our ATU, what I'd like to do is make this a very, very short piece of coax, because this could have a possible, let's just call it not 50 ohms. And like I said before, if we put something that isn't 50 ohms on a piece of coax, we're going to be, if it's 50 ohm coax, you can get 75, of course, for sort of TV and satellite use. But that's not going to be 50 ohms, or not 50 ohms if you're into C. There we go. So we're going to have a lot of losses on there. So let's keep that as short as possible. And then we're going to put a Balun in the way. So this is our Balun. And Balun stands for balanced to unbalanced transformer. So this is our unbalanced end, and this is our balanced end. And we can connect our ladder line into there. And that will perform our unbalanced to balanced. Now this is a transformer. It's literally a 1-to-1 transformer. We can also perform another trick here. This could look something like 200 ohms here, which is sort of the impedance of the ladder line. Now, if we've got 200 ohms-ish, and we want 50 ohms, we need a 4-to-1 Balun. And I think I showed you last week, I went out and bought some. This came from AliExpress. Wasn't a lot of money. I think it was about £15. And I've also got a 1-to-1 just to try some experiments with. So yeah, that's the sort of plan. And that lead here we're going to keep very short. The idea originally was to house the ATU outside in a box and build the Balun either very close to it or inside that waterproof, weatherproof enclosure that I can just attach the ladder line straight to. Now, you'll also remember in last week's episode, I mentioned I'd done this previously. It was early noughties, I think, where I had a doublet on the roof of my old house. And there was a box that housed exactly that. Well, no, just housed an ATU and fed the doublet. I didn't use a Balun back then. So, yeah, what I did, insert photograph here, you can see that. There's an ATU in a box at the top of the mast that feeds the doublet. And, yeah, it worked really well, especially on some of the higher bands, sort of 24 megahertz. I used to get over to the States quite regularly on sort of 50 watts, so it was quite good. So that's what we're thinking about. Now, a couple of days ago, I had some work to do on my Classic Mini. I didn't film it because it was a bit dull and uninteresting, but our safety chaps here took a rather dim view of the front subframe mounts, so I had to replace them. So while I was in the garage, now recently in the garage I've had a bit of a clear out, and I must do the same in here because it's getting beyond a joke. I've got kit everywhere. But yeah, I've had a bit of a clear out and I eBayed some stuff off. And in one of the boxes, I found this. And if that looks familiar to anybody, that's the box that was up the mast. And yeah, there it is. This is RG58, not a very good coax, but probably good enough for our needs because it's not going to be a very long length. Let me zoom it out a bit so you can see. That's better. Hang on, let me just adjust that. That's better. This, I presume, is the DC power. Now, I opened it up just to prove the point, and sure enough, it's an SG239 HF Smartuner. Some dodgy wiring on the bottom of it. The coax is mostly unpleasant. But here was the surprise. Back in the day, I'd already built a sort of Balun out of a bit of mains lead there. And I've just counted this up. This is in fact a 1-to-1. So my output was indeed properly balanced. Although actually the antenna wasn't. The antenna was a bit longer on one leg than the other. But this is a 1-to-1 Balun. So what I'm going to do, to be honest, that's probably not a big enough toroid. I know I used to run 50 or maybe 100 watts, but I'm wondering if that was coping. So the plan is actually to reuse this in its entirety. There's probably nothing wrong with it. It is an automatic tuner. What you do is you put a bit of RF into it. It tries to transmit into the antenna, looks at the impedances, and just the same as this Chinese kit will, it'll switch relays to switch the inductors and capacitors in to get something that looks like a 50 ohm match. There's some notes on here. The SG239 universal coupler is designed for use with any HF transceiver or any HF antenna as specified. Warning, high voltage present. Yes, well, that's going to be out of the way anyway. End fed antennas, you want radials. Yep. And they say it can be balanced or unbalanced, but I think putting a 4-to-1 Balun in here is just going to give it a bit of an easier life. So yeah, so I think the first thing to do is to see if we've got a better toroid, or even, where are we? Try and mount one of those in there. That's going to be really tight, isn't it? Yeah, that's not going to happen unless I take the insides out of there and have a look at it. I mean, they say that's rated for 200 watts, so maybe if I cut the caps off, we could make use of that in there. But yeah, anyway, we've got some bits, so that's the plan. I'm going to see if I've got another toroid, and then we will see what we can do, winding a Balun, or maybe cut this one apart. I wonder if we do that anyway, because it'd be quite interesting to see what's in there. Yeah, whether it's a genuine Balun or not. Right, there's the plan. Let's make it happen. Right, first thing to do, I think, is to remove this old 1-to-1 Balun from here. Obviously, our screws have become lost from this tuner at some stage. I've got a sneaky suspicion I soldered them on there because it's an American tuner, and I think the screws are Imperial. And I didn't have any, so there we go. All right, we can. There's some sort of hot melt around here to seal these leads in. I wonder if we just cut that off actually and pull it out. Yeah, there we go. Let's get rid of all that. Right, I'm just going to put that to one side for a minute. This toroid is quite small, and it's smaller than these I've got here. So I've got a bucket of these from MA Components. I won't need those 3, I don't think, but these 2, what I'm going to do is I'm going to stack them together, tape them up, because the bigger the sort of area of core we've got, the more power it will take. So that's good. Same as any transformer, really. You know, obviously a 1,000 watt transformer is bigger than a 10 watt transmitter, and it's to prevent the cores from becoming saturated. Once the core becomes saturated, it just gets very wasteful. So we don't want to be getting hot, really. So there. So I think 2 of those together will probably do us. I'd rather something a little bit larger, but these are the biggest I've got. So this is what we should be using. So I'm just going to tape these together. The saturation of a transformer, by the way, it also depends on the frequency in use. So at lower frequencies, you're much more likely to saturate a transformer than at higher frequencies. I'll tape that together. Right, it's going to hold the toroid together. Now, the other thing people go on about is, oh, you should wrap it all in tape to make sure you're well insulated against your wire, even people using enamel wire. well, you've got to really throw some voltage at those wires. Now, I know the voltage at our output here is going to be higher than our voltage at the input, but toroids don't conduct. I know they're made out of iron powder, but they don't conduct electricity. You might get a bit of interwinding short, I suppose, but you've really got to be pushing some power. And I don't really do the high power thing, so that's going to be more than adequate for my 50 watts, I should think. So now we need some wire, and I'm just looking at what I've got, and I'm not very impressed. I should be right back. Okay, that's the toroid. This is all I've got. I was looking for some enamel wire, sort of stuff that you have to sort of sand the ends before you can solder it. Don't have any of that. What I have got is this rather stiff equipment wire, but this is Teflon coated. So it's got a really good insulation rating, if you like. It's not very thick though, which bothers me, but hey, let's put it together and see if it works. Now, the first thing I want to do, I want about 10 turns on each side of this. So the first thing to do is just to see the sort of length we've got on a complete turn. Come on. So that is one complete turn. One turn equals, and the toroid disappears off onto the floor, 12 centimeters. So yeah, we're going to want 120 centimeters minimum. We'll add a bit more on. If you're in American measurement units, you want, what's that, 4 3/4 American units, and that's for 2 of that size toroid. 120s, I think. 120s. Yeah. So right, I want 1.2 meters of this. I'm going to do it in pairs like that because it's very easy to see. Now, a while back, DX Commander and Mike, oh, what's his call sign? Lives in the next city to me in Gloucester. I must see if I can get in touch with him actually and do something together. They made one. They made it using enamel copper wire and a dirty, great big toroid. It was a super bit of kit. And he started off with a fold at this end and wound it that way. Really clever way of doing it, but then he had to use a meter to work out his tails. If we do it with this, we can instantly see which colours are which. Right, next thing, I'm going to need some zip ties. One moment, because I've just put those away. Right, that's a chunk of zip ties there, just so I'm hoping that will go round. Ooh, will it? Just enough to hold that in place. No, they're going to be too short. I'm doomed with this project all of a sudden. Right, we've got some 4.8 zip ties. These are a bit of a chunk, aren't they? But they'll go round. Yeah, plenty. Right, okay. So start off with, we need to measure out 1.2 plus meters of that. So that is, ooh. So that's 4 lengths of wire, about 1.2 and a bit long each. So just to start us off, let's get one piece. Let's put the other one over there for a minute. What I'm just going to do is I'm just going to put a bit of that nasty electrical tape around the end just to hold these together to start with. If I start dripping sweat everywhere, by the way, I must excuse myself. We're having something known as a summer here in the UK. and it's been 30 odd degrees yesterday, not quite so bad today, but this workshop is roasting at the moment. Right. That's the start of one winding. So just going to use a zip tie to hold that in place to start with. Just hope I can get that tight enough. That'll hold it. So now we start winding. So every time we make a complete circle, that is one winding. So this is winding 0, believe it or not, because we haven't gone through the hole the first complete time. I want to try not to cross these over as well. So keep it red, yellow, red, yellow, red, yellow all the way around. So this is 1. I think that's about all we're going to be able to fit on this core, by the look of it. How many have I got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I've got more than I thought. That's all right. I'm just going to put a little bit of tape on there just to hold the end. That's horrible. Let's do that again. We've crossed one over there. Let's put that right before we stick it down. Well, I'll tell you what I have got that'll be rather nice, a bit of Captain tape. Captain tape. Lovely. Just the job. That'll look very professional. Okay, so that is half of our transformer wound. So now I'm going to get my other pair and I'm going to wind in the opposite direction, which actually, if you look at it, seems to be the same direction. So what I'm going to do is I'm going to start here and work my way back that way. But it is in fact in the opposite direction. So let's do that. I'll put another piece of Captain tape on there. It'll be just the job. I've lost the end. There it is. Right. Same again, 12 turns. Doesn't really matter how many turns you have, as long as you have the same on both sides. Thinking Callum and Mike's Balun, I think they only had 5 turns. There's some really thick wire though. Really good for probable QRO operations. Right, that's after some minor adjustments through for mathematical errors. That's it. So we have 2 windings, this one and then that one and that one. I'm just going to put a reel of Captain tape all the way across here. Just going to even it up a bit, just to hold it in place. Maybe I'll just stick a zip tie all the way around. Will that reach? We haven't had very good luck with the zip ties so far, have we? Oh, that's perfect. Maybe I'll just put one around the top and one around the bottom. Yeah, that's just holding that all in snugly. That's good. Just tighten that up. There we go. Put another one in that side. Okay, now we've got to wire it up to actually perform like a 4-to-1 Balun. Okay, so just at the moment, it's quite a configurable thing because we could actually wire this as a 1-to-1 Balun as well. But that's not what we want. We want 4-to-1. So it's symmetrical at the moment, so it doesn't matter whether it's that way around or that way around. I'm going to go with this way around just because I am. It doesn't matter. So we've got this side, we want to be 200 ohms. So I'm just going to cut this excess off here. Now, the inner 2 windings that have appeared at this end, so one red and one yellow there, so those are the inside 2, we're going to want to put those in series. So I'm just going to cut that there, get the wire strippers out, bare these 2 ends out. Oh God. That's it. And I'm just going to put those together and solder them up. Put a bit of heat shrink around there. Pity I damaged that, never mind. That'll solder onto our connector anyway. So let's just solder that up. Lovely. Get a piece of heat shrink from my famous SAT 101 heat shrink box. What do we fancy? We don't want anything too effusive. Looks a bit small. Let's go with that bit there. Just going to sleeve that up. Hot air gun. I should use this blow lamp. There we go. Right, that's all insulated up. Excellent. So across this end is now going to be 200 ohms. And at the 50 ohm end, what we've got to do is we've got to put the 2 yellows together and the 2 reds together, and they will go onto the 50 ohm end, or the output end, if you like, of our tuner. Because of course it won't be 50 ohms. The good bit about this is, of course, we haven't got any coax in the way. So we will have a very short run of something a bit lossy, but not massively. That's the plan. Right. So let's just get the tuner unit back up here. Right, so that's our 200 ohm output end. That's going to go to our connectors for our ladder line going off there. And these are going to go to that bit there. So how am I going to fix this in? This doesn't appear to be fixed in either. I suspect it was once held in with hot melt or something. Oh, double-sided tape. Yeah, well, that's long since failed, but I'm not particularly worried about it because once it's mounted up, it's not going to go anywhere. I think the next thing to do is to actually make some connectors here to take the ladder line. So I think what we might do just get rid of this hot melt glue. From here. Oh, talking of Satomatics, this is an Ocean Alert SSAS enclosure. We had a lot of them scrapped, so I did recycle a lot of them back in the day. Crumbs, that's got to be 20 years ago now. Right, I think some nuts and bolts through there might be a good idea. So see what I've got. Something nice and stainless, perhaps. Oh, those look good, don't they? We need to drill the holes out a little bit. And have I got matching nuts is going to be the big question. That looks promising. Excellent. We shall go with that. So that needs to come out a little bit with a drill bit of some description. Maybe a little bit large, as small as possible, and then the chances of water ingress will be dramatically reduced. I shall seed it probably with a little liquid rubber anyway. I think that will do nicely. Right. That's excellent. So if I get some ring terminals and crimp them onto that end, can sit like that. Maybe it could sit better like that. Oh, it's not quite. Oh, it will. See if I can squeeze that around a bit. Yeah. Look at that. Right, that appears to be a bit of a goer. So let me go and see if I've got some ring terminals. Right, so a couple of ring terminals. Just going to solder those on there. They're a bit big, but hey, it's what I've got. Just tin the terminal up. Crumbs, that's hot. Took ages to set. Right, there we go. Same for this one. Right, next stage. So they're going to go under these two bolts like that. Put a bit of a spring washer behind it, shall we? A bit of a chance to bite in a bit. Then one's to RF ground and one's to RF hot. Those terms are largely irrelevant now if on the balance side, sorry. Should nip those up in a moment. So let's make these connections next. Okay. I'll try and clean these terminals up a bit. It's taking solder okay. To say, this silver wire just takes solder so well. Phenomenally expensive stuff, but just so nice to work with. Oh, hot. I'll take that one round like that. Right, well, that's electrically at least complete. So let me find my box of Allen keys. There they are. Just tighten those up. Put a spot of liquid rubber on them. How big are we? Bigger than that. Could it be that one? Smaller than that. It'll be the one that's missing. You know it's the truth. Bigger than that. Oh no. Really? That's the one. Hallelujah. Where's my spanner? Right, I shall now take note of the colours down here in this bit of mains lead that's not doing mains. We have got brown for 12 volts, ground is blue, reset is green. I don't think I ever used that. I think it was always pretty good. What I am going to do is just seal some of this now with a bit of liquid rubber. Well, it's not very pretty, is it? But it'll do nicely, I think. Yeah. Right. I'm just going to wait for that to go off and have a cool down, because it's still roasting hot in here, despite the fact it's now 8 o'clock at night and it's still absolutely scorching. Right, back in a bit. Right. All my rubber's gone off nicely, and that's all no longer moving around. So yeah, quite pleased with that. Next thing remains to be done is to screw it up outside. Put the lid on. I actually put a blob of rubber in there. I wasn't entirely convinced. And this bit of plastic over the old Ocean Alert key switch. But yeah, I'm happy with that. This box has a separate compartment. It actually seals on this inside ridge there. So these screw fixings are actually outside, so they won't affect its watertightness. But in talking of watertightness, one thing we do need to do is there's no sort of breather hole, and well, there ought to be really. So we need a 3mm hole, sort of in the bottom here somewhere, just to allow air to move in and out as it heats and expands and contracts, I should say. So 3mm is the magic size where it'll let condensation out as well, so without water being able to enter. There we go. Let's just take the burr off that. Lovely. Right, let's venture outside and fit it up. I think I'll just drag the cables in through the workshop window for the initial test, because currently the workshop being in such a bomb site, I've not got a sort of operating position, so we'll come back over here, set up a radio and see if we see where we get a match, and see if it works. I understand that conditions on HF aren't great at the minute, but we're about to find out, aren't we? Right, let's pop outside. Right, the next thing to do is to put the antenna up, cut the line to the right length, put a couple of ring terminals on there, and terminate the ladder line to the top of the control box. So now all I've got to do is open the window, put the wiring through and give it a test. Okay, so I've got the antenna connected to my trusty IC706 Mark II-G. The antenna tuner is powered from a power splice just out of shot, as is the rig. And we're on 10 meters. So yeah, let's see if we can get a match on this band. Straight away, that's the when in transmit, this is SWR down here, so we're looking for anything below that sort of 2 mark there for a reasonable batch. Well, yeah, we've got something there, so let's go down to 070, see if we can hear any FT8. I have to say, I don't think we can. Right, let's drop down to 12 metres, a little bit out of band there. So, right, if we go right to the top of the band, try tuning up here. Right, push the tune button. Not a good match, but you can see it's sort of hunting about. And there we go, we found a match. So it's only 100 kilohertz wide, so no, nobody much on there either. Okay, let's just disable the tuner. So 21 megahertz, 15 meters. So let's hit the button there, see if we get a match. Oh, there we go, we've got a match. So there's a CW station in there. See if there's any okay, so that's 21 megahertz, 15 meters. Let's go for 17. 18.68. So I'll come down a bit from there. Right, let's push the button. Once again, we've got a terrific match. That is very, very strong. Look at that S9 of FT8. And there they all are singing away on 17 meters, so that's encouraging. And 68's the top. Nothing much else going on, but hey, see if there's any CW going on below. No, maybe not. Right, next one down is the all-important 20 meter band. Wow, we can hear somebody there already. So let's just briefly tune up. I'm a 1-to-1 straight away. Oh, bang the camera, sorry. See if it goes transmitting. Right, so we're definitely doing things. That's good. That's 20. Right, 30 meters is a very narrow band. Yeah, it's only from 0.1, 10.1 megahertz to 10.150. So it's quite a narrow band, and it's sort of CW, and I think there's an FT8 channel on it as well. But right. Again, you can see the tuner hunting, and we have 1-to-1. No, 30 metres is very quiet. 40 metres would be an absolute bonus. So let's hit that tune button. We have 1-1 again. Awful lot of noise on here. I suspect if I go around my house and switch off stuff, I suspect we'll find that calms down. Again, plenty of activity on FT8. The wailing mode. Bound to have some CW down here as well. I would have thought so, but maybe not. Right, this is all starting to get a joke now, because here we are on 80 metres, so it's 3.5 to 3.8. Do you look at that? Shade over 1. That's incredible. Now, this doesn't, just because we've got a match, doesn't mean this antenna is any good. It could just be that we've, that we are, it's far too close to the band. Far too close to the ground. So certainly on these lower bands, it's going to be doing a lot of warming up of the earth around it rather than actually transmitting. But hey, at least we've got something. Too much noise on 80 metres. Right, the biggest joke of all, will it match top band? Now, I'm not a top band user, so I'm just going to check that I am actually on frequency. I know I should remember this. 1810 to 2 megahertz. So yeah, I'm in band. Oh, it's going to struggle. No. It's still trying. Come on, you did better than that before. Oh. Two to one. 2 to 1. Horrible to 1. Unsurprisingly, it doesn't work on top band. But I think that's a pretty spectacular result, really, especially to have 40 metres working. That is quite impressive. So there we have it. Right, I'm going to sit here and try and make some QSOs now. Thanks very much for dropping in and taking a look at this antenna. I will let you know how the performance goes once I've had a chance to sort of make a rack for this radio. So I've got an operating position again because it's all been stacked on shelves. Yeah, for far too long now, so it's about time we had some fun with that. Anyway, another thing I've got to say is I'm going to be probably not making a video for a couple of weeks. I've been doing a video a week now for months and months and months, and quite frankly, I'm a little bit burned out. So I'm going to take a break from it, but rest assured, I will be back very soon here on Doz's Television Workshop. So thanks for viewing, thanks for watching, and I'll see you very soon. Cheers now. For God's sake. My friend Crispin's just WhatsApped me. I watched your recent YouTube video, but must have missed where you said what you're going to be able to do with the enormous aerial you're erecting on the back of your house. Wow.
The same thing we do every night, Pinky. Try to take over the world.
Oh well, it saves me the bother. Thanks, Wayne. Yes, that's Wayne. His channel is Mega Wayne D. Look that up, click like and subscribe, etc, etc. Wayne does some telly stuff, some silly humour stuff, and welds up an Allegro on Chris's TV channel. Oh, this is too wordy.
Thank you, Sierra 57, Outtakes.
Golf 7, Golf Quebec Alpha.
Alpha Kilo Mike, QRP, and Portugal. Good evening, Q5 and 9. 73, have fun. Sierra 57, Outtakes.
Golf 7, Golf Quebec Alpha.
Golf 7, Golf Quebec Alpha. Good evening, Q5 and 9.
You're 5-9 also, Franco, 7-3.